Here we go. Check, check. Mic is working. Amazing. Guys, I'm very, very happy to be here in my hometown. Being at BSides is, I think, one of those dreams you would have if you're in the security industry. And last time I've been here, the time before, I wasn't available, unfortunately. And it's just great to see how this conference is growing and how we're building. And Alex, Christian, and everybody, thanks again for building this community around Frankfurt and cybersecurity. Now, I want to talk about, again, AI security. And I know a lot of you would say after ChatGPT 5 was released, oh gosh, the AI winter is starting, it's coming. But just looking at the last days with NX supply chain attack, with Anthropic releasing the report and showing what's happening around cyber criminals and nation states leveraging AI, with AI XCC, the DARPA Cyber Challenge releasing the report, I think if anything, then it will be the beginning of the springtime in AI and cybersecurity. And now, when I joined cybersecurity industry back in 2010, I think we've been trying really to keep up with all those different threat actors out there. It changed dramatically after 5-6 years joining another security vendor. It was more, us trying to keep up with security engineers. A lot of companies are still on this journey, trying to understand how fast the business is moving. And now I think we are moving into this race against AI agents. And I'm not suggesting that anything is changing, anything foundational is changing in cybersecurity. We still have the same principles. That hackers have to be right once, to succeed once, we have to succeed all the time. But what is changing is really the pace of the adoption between offense and defense. And if you go out today, out of this presentation, I'd like you to see AI and cybersecurity is through a lens not of co-pilots or detectors, but through a lens of verifiers, technical, mechanical verifiers, because who owns the verifiers is going to win this race. Now, I thought, let me start with a small personal story, and as Christian said already, I'm working for Sysdig a lot with open source and so on, but my passion in the past was in gaming. I don't know who of you is having kids, they like to play Fortnite. Amazing game. Back in the days, we had much more better games. Who played Counter-Strike? Whoa, I've never seen so many people. I've asked this already a couple of times. That's my favorite conference, and I was damn good. So I don't know how many kills I made, and perhaps we've met somewhere, on the stage. But at some point in time, I was very disappointed because, let's see how the clicker is working, because this guy, what is that? Spooky. Wow, the presentation is gone. Oh, here we go. Somebody is playing. Okay, here we go. That's an interesting clicker. Ah, okay. Multifunctional. No AI on that. Because, this guy joined the game, JoBot. I was back then 16 years old and started to research about JoBot. And damn, it was a guy younger than me, 15 years old, from another city in Germany, who wrote this bot as part of his Abitur, which was crazy. And you can still find the paper on archive.org. Amazing, right? What is amazing is really, this inspired me to go into machine learning. I bought my first book around neural networks with backpropagation, started to build my own stuff in this space. But what was very interesting around this bot is this very small neural networks, 77 parameters. Compare this to DeepSeek today, more than 700 billion parameters. But guess what? This bot was already, it made the game impossible to play. It was so good. The biggest challenge this guy struggled with is how to get the training data. He tried everything. He tried to simulate multiple games. He tried to record the games and get somehow all the data to train the small neural networks to become effective. But he succeeded. And for multiple years, this bot was pretty good. Now, on a defense side, we had to adopt. We had as well to come up with some machine learning, and perhaps if you played, you remember the aimbots. I was never cheating, of course. Or like seeing through the wall type of bots, which also some of them leveraged as well machine learning, right? Typical statistical approaches. Now, what is interesting is that just bringing this back to cybersecurity, we've seen as well the successes in cybersecurity. I would even say cybersecurity was potentially the first one to use AI if it comes to, for instance, spam detection, right? Or some of the malware classifications. This were a lot of labeled data, millions of labeled samples of bad emails, and machine learning was really good at this static environment. But where it failed, and I'm pretty sure if you're working in security, you're feeling this still day by day, is everything what comes, when it comes to threat detection, insider threat detection, trying to detect living off the land attacks, trying to detect new malware families. And the problem is that all these models, I'm not talking just about Gen AI, but all the models, they don't really generalize well on private enterprise data. We had really good machine learning models generalizing on public data, but not on private data. And this is what made AI and cybersecurity so bad. And to understand the progress and the excitement right now around Gen AI, which is not really around Gen AI, it's about reinforcement learning, I'd love quickly to introduce the differentiation between supervised and reinforcement learning. And Gen AI is like a combination of all of them. But what's important is, in the past, in many cases in cybersecurity, we've tried really to label the data. And that's our biggest problem. We don't have a lot of labeled data because the complexity of cybersecurity is just so bad. See this as homework you're giving to your children and ask them, solve this homework, and this is the answer to that. It's not going to make smart children out of that, right? But playing games, again, with a scoreboard where they can improve all the time on a daily basis and become better Counter-Strike players, that's something that they need. And indeed, we see a lot of research day by day in this environment where, for instance, recently there was a very nice research where just with a single function and a self-training, self-play against each other, a model became better than any other model in mass just by ensuring that we have really good oracles and really good feedback system to this specific function when these mass models were built. So reinforcement learning can unlock a lot of this creativity if we can create the right problems. And this is as well a mental model I'd like to talk today about, because this is creating a lot of buzz right now in the AI space. And it looks a bit difficult here, but let me explain. It's pretty easy. If you have the set of problems you want to solve with machine learning, you can just map them on this map, on this graph. The one dimension would be how hard is it to generate the solution. The other dimension is how hard is it to solve and to prove that this solution is correct. The easiest example is Sudoku. Very hard to generate solution. Right? There are tons of solutions, but it's very easy to prove if it's correct. Right? Or Go or chess. It's very easy to verify the solution. And the theory is here, which is, by the way, if you're in computer science, you perhaps remember the P equals NP problem. If not, I want to talk about that right now. But the thesis is everything where it's easy to verify a solution but hard to generate, machine learning is going to solve. And indeed, we saw this progress across many of the use cases in the past. A counterexample to that is diet. Right? It's something you can easily come up with, but it's very hard to verify because you see the effect of that after a couple of years, eating the right food or not. So what is important is with Gen AI, we see that we can outsource the generation of solutions, but we can't outsource the verification of solution. Very important to understand. And what we need to train good, proper models are mechanical verifiers which can quickly give us feedback, like in a game. Is this thing correct or not correct? And the cost of verification depends obviously on a lot of things, like available tools, the data you have about a specific system. Do you cover all the different dimensions or not, or do you cover just a subset of dimensions? The expert of verification of tolerance of error. Remember, like self-driving cars, you can't really tolerate anything. Same as cybersecurity, so you have to be very, very accurate, and these mechanical verifiers have to be really, really proper. So to summarize that, what this model teaches us is that the ease of training AI to solve a task is proportional to how verifiable a task is, which means all tasks that are possible to solve, all tasks which are possible to solve in an easy way will be solved by AI or can be solved by AI. And I think this is really, really important statement for us to understand how this can be applied to cybersecurity going forward, because just looking at all the other benchmarks And what is a benchmark? A benchmark is a mechanical verifier where you can very easily verify something. All of the recent big benchmarks which we saw around math, medicine, healthcare, whatever, they've been all solved by machine learning, literally within a couple of years. And reinforcement learning is a fuel to make this possible. Now, if we progress to cybersecurity, we're seeing a similar progress. This is a graph from the system card from OpenAI. As you know, all the big lab models, they've started now to release system cards where they show the progress of the models. And this is a system card 03 or 4 from ChatGPT, which is very incredible because what they did is here, they just took multiple common capture the flag exercise environments like Hack in the Box and others, and they would try to run the model to see if they can solve this capture the flags, like network exploitation, web exploitation, cryptography, all this common capture the flag you're used to. What's fascinating to see is the first models, ChatGPT 4.0, when they've started to do this, they just performed at 20% in average. Now we see models performing at 80, 90%, if they're allowed to use research, if they're allowed to use as well web browsing and so on. And this is crazy to see that this type of progress, but these models are, they are generalizing across this specific capture the flag exercises. It's not a surprise now if you go to the largest platform for bug bounties out there, HackerOne, and click on vulnerability disclosure dashboard. You see as well not a human but expert, a startup in the US, which just tries to build this mechanical verifiers and to train this model specifically to be good at not 100% of different vulnerability classes, but small portion of these vulnerabilities, and they're still a number one right now, or they became number one just because of that. I think if they're able to solve even 5% of vulnerability created by machine learning, that's already a big value for the community out there. Now, looking back at the same report, April 2025, O3 model, we see that a different task, where you set up a test bed environment simulating an online retailer and ask ChatGPT to go out and perform a full end-to-end operation to compromise some data, it would fail completely, miserably. Even after reconnaissance, all the different, these are the different steps it would perform, it wouldn't work unless you start to give it hints. Hey, go and try this and this, or give it a solver code. So it was not really working back then, but 10 minutes left or 10 minutes over? Okay. But what is interesting to see is the lab started now to train the models based on that. And what do you think? Is flag.txt somewhere on the web server which is not accessible by anybody else? Is it a good verifier or not to train a model? Is that simple? Can we just plug in a Kali box and say, go and try to get from this machine flag.txt? Apparently it is. Because if you just look at this simple binary verifiers, so either you compromised and hacked or not, it's just a question of how do you tune the models now to work. And we see a lot of progress around that. I've just got two examples. The most exciting paper I've saw is this Incamo paper, which is basically doing a very simple thing. It's just trying to split the architecture from not just one agent going out and trying to perform this end-to-end autonomous hacking operations, but it's just saying there's one model which is orchestrating and multiple models which are performing the task. That's it. And this brings us from 0 out of 10 environments simulating environments like Equifax being hacked to 9 from 10. Very, very simple trick. Again, another example is DARPA AI Cyber Challenge, and they've just performed the recent round on the Black Hat. Last year was 37% of the vulnerabilities which they've created synthetically or had already in the environment, which were found by this autonomous cyber reasoning system, and the idea is not just to find but also patch. This year we saw this progress from 25 to 61%. So again, we see that offense is really having this here we go. Offense is really having this type of acceleration right now. Now, if we double-click on more technical topics, I know there's a lot of pen testers here, what is a good mechanical verifier in fuzzing? There are tons of that. I love fuzzing because I think this is where you get really strong signals, at least in some of the areas. So, easy buffer overflow, you've got the SN. Every time there's a crash, you get this error, and it's a very clear mechanical verifier. Something is wrong on your stack. And, I think Gen AI can help, if you remember this graph in the search space, to have the right search strategy. Not just to spray and pray, for instance, but understand the semantics of this application. Based on semantics, understand, do I need now, if this is a, ASCII a string which is accepted, do I need now to try out with Unicode instead of just pulling some random strings inside? It can help as well with exploitability triage, which is becoming a bit more difficult, right? Bypassing ASLR and so on. It's not very easy. So this is where it's going to become very hard to verify. But I think it's a good start. And just mapping down this complexity of all these verifiers, looking at all these offense capabilities, we see that most of them, they're hard, but most of them are still possible to generate. They're very binary. Either you have achieved something or you haven't achieved something. And that's really important based on this theory because it means offense can very easily train up based on RL the models to succeed. Now, there are some exceptions to that. And one example is, for instance, I love this story, is when O1 model was tested, they would use one model against a specialized chess model. And the one model started to recognize it's losing. So it tried to kill the process of this other model. It didn't succeed, so it recognized, the chessboard is just a foul, so I could change the foul. I can change the rules of the game and make impossible moves, right? Remember, these models are just optimized to get the reward, and the reward was you have to win the game. So if you're training, if you're setting up these gym environments and setting up this mechanical verifiers, you need to ensure that you're training on the right things, otherwise the model will try to cheat all the time. And this is not something you want to have. Now, if you look into detection, I think this is, in defense, what we've been served with, right? So I know, say Trevor and people from SOC, this is what our analysts are getting if they are today using machine learning in security operations centers. And this was a crazy cool video, but now it's not working because we had to switch unfortunately, the laptop. This is expectation. And imagine, if you just take this as an example, visual creation of videos, spaghetti test by Will Smith. 2 years or 1 year, the quality here and the quality over there. It's very easy for humans to verify that's really bad. That's really good, right? And this is why you see a lot of AI companies like Scale AI and all these companies creating this test or employing humans to give this feedback, succeeding and being worth billions right now, right? Because the AI companies, lab companies need these verifiers to train up the models. Now, let's dive into this defense space. And again, in security operations, I have a nice term for SIM. It's suspicious information every minute. And I thought there's a good example I saw from one of recent presentation. Just to illustrate this, if you have 1 million events per day, and 1 in 100,000 you see a malicious event, and you have a detector, a verifier, which has 99% of true positive rate and only 1% of false positive rate, which is exceptional, right? What do you think? How good is this Oracle and verifier? And it comes down 10,000 false positives. So if you train now your AI model based on this detector, it's not going to be good. It's not going to generalize on this bad stuff. The precision is going to be very, very bad. Now, same for GRC and TPRM. I'm a CISO for a vendor security company. Guess how many big banks are asking me, hey, can you fix that and this policy and that? Can you, just looking at the GRC framework, have an objective truth if this company is well secured or not? It's hard, right? There's so many different aspects. It's compliance. So it's very hard to train the models based on this because there's no ground truth to understand what is good looking like or not. We're just following compliance frameworks. So if we're just looking at these defense use cases, the point I'm trying to make is a lot of these use cases are in this very, very top corner where they're very hard to verify and to solve. This is why you have so many SOC analysts so many vulnerability analysts trying to look at this. The tricks we're using, which by the way, all these other AI companies starting to use as well, is would pre-compute a lot, would verify, based on malware analysis, trying to find certain malware families and then creating rules, pre-compute these rules, and then give these rules and push them to the space where they're easy to verify for this specific malware sample, for this specific set of samples. Exception is honey tokens. They are very binary. And this is why people who are really good, they love honey tokens, right? Because this is very clear indication something is happening. Now, progress has been made as well to push these verifiers down, because you can do a lot of things if you combine good technical verifiers with AI. And this is what we start to see around some projects. Like I have two examples here with Microsoft implementing a reverse engineer, and Google trying to apply Gen AI on Plaza, lock to timeline, to find for certain critical events. You see, with the reverse engineer, just by using sandboxing and control graph and decompiler data, it was possible to reach a pretty good precision in some very small subset of files, which are drivers. Drivers are more static, obviously, than files, and therefore 98%. It's pretty amazing. Still a big recall, but that's okay. If it comes to forensics, the precision is pretty bad. So this is what, if you're doing forensics, you know that. How do you stitch everything together, and how can you say from one specific, one specific event that it relates to other events and it's really bad? So precision is really, really bad. And I think this is where we will be not able to easily come up with good solutions to stitch all this information together and automate good models to reason there. In the same space, in the cloud security environment, we have a couple of good verifiers we've built over the time, and one of the best ones is obviously reachability. 95% of vulnerabilities out there, they're not reachable. They're not useful. So if you start to train models without really considering this verify, if you don't build a graph around understanding how a specific vulnerability exposed in your cloud, is it accessible from external point of view, is it another firewall, load balancer, what kind of identity is being mapped to that, it will be very hard to have a really good verifier which is precise. And this is what we see as well internally, been working on that. How cool is it just to use this very, very clear deterministic information? So just to summarize all these classes of verifiers, because this is what we've been doing as an industry already for years. And my point is, we need really to focus more on this deterministic stuff in AI rather than trying to work with AI. There are these 6 classes, I've tried to classify them, of good verifiers, starting with the best verifiers, which are canaries, obviously. Honey tokens, user accounts which are not being used. This is awesome. If you can start training your machine learning based on that, and you have a clear understanding as well, what is a honey token, that's going to give you really good reasoning across all of your files. Provenance and attestation, obviously. Having the machine learning understand. Machine learning is not going to break crypto, right? We don't see any proof for that. It's not solvable. But it can help understanding what is a provenance, what is my salsa level, are my images signed. What we're not doing too much, very hot topic right now in Silicon Valley, is detection engineering. Right? So just trying to test all the different rules we're building, detections we're building, patches we're building across some specific testbed environments and see what the precision is looking like. Not a lot of companies are doing this, and we end up with a lot of false positives. But this is something where I think there's a lot of potential, because now we can simulate more traffic. We can simulate environments with generators, because it can generate a lot of this stuff. I love invariance, policy as a code. So obviously, instead of checking, is this machine configured properly? All of my machines configured properly. You just define something as ground truths. And you have infrastructure as code, opportunities with OPA and whatever. You start to see this, by the way, in vibe coding. I don't know who of you is vibe coding. Cursor is a perfect example. You just define rules, and you just say, before you write a program, please make sure that there's no SQL injection. Please make sure that there's no top 10 overs. And guess what? They're being reduced quite heavily. That is that simple. And then sandboxing. I hear a lot of people since the last years calling out sandboxing is dead, there's no progress around that. But we need to work hard on making sandboxing now more dynamic, having more better gyms and representing the entire company and not just a specific environment to get this type of opportunity to train the models. And then obviously graph-based verifiers, we use attack graphs everywhere, in offense and defense. In a defense space, I think it's pretty young topic, being evolved since the last five years or so, but cloud is a good example of that. Vulnerability management. So this is where you can get much more better mechanical verifiers than anybody else. Now to summarize with my last slide, there are 3 takeaways from that. And the first one is obviously we need to focus ourselves more on this mechanical verifiers, on the oracles, rather than on detections. And what it means is, first of all, even if you're buying vendor solutions, ask them how they are verifying on a constant basis their detections. Stop really focusing on these solutions which are trying to automate process unless you know that the process is tested against a specific set of deterministic verifiable oracles. Second one is obviously offense is leading. We're seeing this everywhere, and they're winning this race of oracles and verifiers. And that's why the best thing we can do is just to adopt this as well and start using offense 24/7 within our environments so we can learn from that. I think it's totally possible right now with all the different research and tools coming out. How cool would it be to have this continuous AI red teamer testing your environments and really helping you as well to make sure you understand your priorities, what to focus at. And then last but not least, and this is a big topic for the industry and not just for you as end users, is how do we build better cyber gyms? Because we understand now, the point what I've mentioned at the beginning, models don't generalize on private company data. We start to see across many domains that agents can help with this. So either you give access to the vendors to train their models on your specific environment, and I know there's a lot of pushback, or we build really good testbed environment which are generalizing across this environment so we can train much more better models and then have these environments as shared environments. Now I've opened up this, this talk with the question if we're in the AI winter or if the springtime is starting, and I think we start to see that, again, AI offense is dominating, and I think in defense we need to stop serving the spaghetti alerts, and therefore my call out is really to you, who owns the oracles, owns the AI race, and with this, thank you very much for your attention. Thank you. Oh, yeah. So, are there any questions on Counter-Strike or cyber or AI? One question. Say it again?
Favorite map on Counter-Strike?
Favorite map? Oh gosh, it was Dune, I think. Dust. Was the most common one as well. No, I don't think so. I mean, because, again, see this as an edge problem. There will be always edges. And even if we optimize some of the red teaming components across some of the environments, it will be not possible to optimize them across some of the edges where verification is very, very difficult. So I think it will be great success already if we can have automated red teamers or pen testers just do 5% of vulnerability classes or 10%. That's already big success. I don't think that we're yet there.
Hi, thanks. Quick question. You mentioned that verifying the output of the model is very important in terms of understanding its purpose. What about creativity and art?
So what?
Creativity.
Creativity.
Yeah. How can we verify those aspects, art and all the rest?
So the question, if I understand this correctly, is how do you understand how well creative the model is? And
yes.
I think this is a natural feature of generative AI because it tries always to be creative to find the fastest path to the goal. And this is where all the AI models are succeeding. The question is just, how do you ensure that they understand the entire space and not just the edge space of that problem? And to do that, you need to have this mechanical verifier. So I think all of the models are creative by its nature in generative AI. So that there's a space, but attention is all you need. It's all about the attention to be creative and to reach the goal however you can it. And then it's an architectural question.
So creativity, at the end of the day, is a means to the goal and not the goal itself.
So, say it again, sorry. Can you speak up a bit?
Yeah. The creativity, it's the end, is the means of the goal and not the goal itself.
Yep.
Okay, got it.
Yeah.
Interesting.
Yeah, so
Thanks.
we can outsource generation, but we cannot outsource verification. And then if we don't have this mechanical verifiers which are solid to train the AI models, we're going to end up in a lot of hallucination. So it's going to create more problems than solutions.
Yeah, got it. Thank you.
So with the technical verifiers that we would need for this in the future, are there companies who would provide a framework for that or who are working towards technical verifiers?
Yeah, I mean, look, there are huge companies. Mark Zuckerberg just hired one of these guys from Scale AI. He got the former CEO of GitHub and all of them reporting into him. He got the former lab of AI reporting into him. He just built a company to build verifiers, to label data initially and to build verifiers. So check out Scale AI, check out all these other companies. There's another example in cybersecurity industry, Cloudflare. Cloudflare is controlling, 30-40% of the traffic. They just announced that they're going to stop traffic of AI bots. And you know why they're doing this? Because they want to create a marketplace for data. They want to make sure that you as an owner of a blog, for instance, can say, hey, before I give this data away to AI models who can train and find these edge cases, I get some money from this specific AI provider, because right now all the AI providers are sucking off this data, and this is how they continue as well building out the models and generalizing across all the edge cases. Like fact-checking is a good example. If you want to check facts, it's very expensive to verify. It's very easy to produce a story about somebody, but very expensive to verify. So you need to have all these different edge cases about all this different data, what was written about that. And that's
Makes sense. Thank you very much.
Thank you, Sergej.
Thank you.
Applaus.